Everyone, welcome back to another exciting day of mathematics. Whoop, whoop. Warm-up number 25 is on the screen. Let's get started, please. Number 1 should be a piece of cake, as well as number 2. I think all of them. I think we should be able to do all 3 of them by yourself. But being that it's Monday, I will go over those, but I'll give you guys some time. Copy and go. All right. All right, here we go. As some of you are still finishing up, let me elaborate on 1A. Look up to the screen. 1A. Last week, I gave you guys stuff that looked like this. Look up, please. It's blank. Oh, yeah, it's blank. There it goes. I gave you guys stuff that looked like this. Is that correct? Now, this we needed to rewrite, and it became 16 to the 1/2 power times 3 because we moved the 3 next to the 1, next to the half, and we just put a 1 on the numerator. Are we there so far? Now, check this out. Look up to the screen. Don't copy this. You already have these. And we said the half exponent becomes square root. What does that mean, Mr. Q? That means that what number times itself how many times? Let me repeat that again. What number times itself how many times? 2. That's why the denominator is a 2. Are we there so far? And then we put that in parentheses to the 3rd power. So what number times itself 2 times gives us 16? 4. And, of course, we bring down the exponent. That becomes 4 times 4 times 4, which is 64. That's what we did last week. So now with that said, look up, please. Let me go over number 1A. Let me make some room. Here it goes. Zoom in. Again, we can't have a 2 on the numerator. It has to be a what? A 1, and I bring the 2 next to that, so this becomes 27 to the 1/3 power times 2. Are we there so far? Yes, Mr. Q. All right. Next, I circle this in blue because now I know that this is no longer 1/2 square root. This is 1 cube, which is what? Cube root. Cube root of 27. Parentheses, bring down the exponent of what? Very good question. Where do I get this 3 from? From here, the denominator. So my exponent here outside is a 2. So question. This 3 is known as the index, and it says, what number times itself how many times? 3 times. What number times itself 3 times gives me 27? Tell your neighbor, one number times itself 3 times gives us 27. Is it 1? Let's see. What is 1 times 1 times 1? 1. 2 times 2 times 2, that's 8. 3 times 3, that's 9 times 3, that's 27. So that number is 3. We bring down the exponent of 2. So what is 3 squared? 3 squared is 9. So what did we learn today, or what did we remember? Because this should have been taught to you by your teachers. What did we remember today? That whenever we have a 1/3 exponent, that becomes a cube root. Last week, when we had, look up, when we had a 1/2 exponent, that was just a square root of 9, or an invisible what? 2. Because what number times itself 2 times gives us 9? 3. So question, what if it did this? Look up, please. What if I said 16 to the 1/4 power? What would that be? Tell your neighbor, what would you rewrite that to be? How do we rewrite that? If this is cube root, that means this is what? 4th root. 4th root of 16. So question, what number times itself 4 times gives us 16. The correct answer is 2. Is it coming back for some of you? Yes? All right. Go with 1B. Let's see, can I simplify the square root of 11? No, so that means I need to multiply the top and bottom times square root of 11. So this becomes 7 square root of 11 over, what is 11 times 11? That's square root of 121. So the numerator stays the same. What do we have in the numerator? 7 square root of 11. How about what is square root of 121? 11, and that's how you get rid of that square root. Are we doing pretty good, yeah? All right, let's go to number 1C. What two numbers multiply to give me 18 where one of them is a perfect squared number? 9 and 2, yeah. And my perfect squared numbers are 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and 5 times 5 is 25, and it continues. So you said 9 times 2, so therefore this is square root of 9 times 2. So what is square root of 9, everyone? That is 3. So we cancel that from the inside. Can we do square root of 2? No, so that's why we leave it as square root of 2. So far so good, yes? All right. Let's go to number 2. Number 2. Here we go. For number 2. What does this 1/2 mean? Tell your neighbor, what does that 1/2 power mean? Square root. That is correct. Square root of 3x minus 11 equals to 5. So now let's use inverse operations. How do we get rid of the square root on this side? Square to both sides. So this cancels that. We're left with 3x minus 11 equals 25. What do I do next, everyone? To add 11 to each side, add 11. So we're left with, I'm going to go over here, 3x equals 36. And our last step, we divide by 3. So x equals 12. And I can do these on my sleep. Let's go. All right, let's go to number 3A. Here we go. Step 1, change this to y form. So y equals x minus 2 over 4. We need to get rid of the 4. What is the 4 doing? Dividing. So what is the opposite? Multiply times 4 both sides. So we end up with 4y equals x minus 2. We still need to leave x by itself. So what do? Plus 2 plus 2. We end up with 4y plus 2 equals x. Is that the inverse? No. What do we do at the end, everyone, to make it the inverse? Swap the y and the x. That is correct. So we got 4x plus 2 equals y. This is what we call the inverse. However, we need to change that to y, f of x. So this is 4x plus 2 equals f inverse x. That's what that -1 stands for. Are we doing good? All right. Go to 3B. Now, if I was to guess, by now you should already be done with that one by yourself, yes? So change this to y equals 1/5 x plus 1. We need to leave x by itself, so I subtract 1. Subtract 1. We got y minus 1 equals 1/5 x. How do we get rid of that 1/5? Remind your neighbor, how do we get rid of that 1/5? Multiply times what? Yeah, 5 over 1 or just 5. Both sides. So if we multiply this in here, it's 5 over 5, which is 1. So we're left with x. Distribute the 5 here, so that is 5y minus 5. Last but not least, switch the variables. So this is 5x minus 5 equals y. And we just write this in function notation. 5x minus 5 equals f inverse x. How we doing? A lot better, yes? Yes, Mr. Q. All right, copy the agenda, please. Today's going to go super fast. I'm just giving you a heads up. Warm-up number 25 is done. Today we're focusing on quadratic equations. Because this week, guys, we're going to focus on systems of equations, linear and quadratic linear. Now, we've been working already with quadratic functions, with linear functions, and we're going to be solving both this whole week. So I just want to make sure that we get some practice in just by solving quadratic equations by themselves. So, once again, warm-up number 25 done. Copy that. Quadratic equations. And tonight's home play, you're going to be solving 8 problems. 8 problems. Once you copy that, get a Cornell note ready, please. All right. So act as the home play. Copy this code, please. SPF 8K. Write that down, please. SPF 8K. SPF 8K. Now, for those of you that were absent on Friday, we had a pop party on Friday. I'm going to be uploading that hopefully by this afternoon to your grade, because I'm going to be sending progress reports home tomorrow. Oh, yeah, I got this. So those of you that haven't taken it, make sure you come in during advisory tomorrow or Wednesday. Or if you need to retake it, again, tomorrow during advisory or Wednesday. Let your teachers know that they can let you come over. All right? So, in case that code doesn't work, here's the home plate. Tell you never where to go in case the code doesn't work. Where do you go to get the home plate? YouTube. Yeah, it's going to be embedded in the lesson, and this lesson is being recorded as we speak. All right? So, get a Cornell note ready. Here we go. I can solve and graph quadratic equations. I can solve and graph quadratic equations. I can solve and graph quadratic equations. Now, for those of you that love algebra and algebra 2, you saw this some time back. Your algebra 1 teacher taught you this, and your algebra 2 teacher should have taught you this again. So you should have seen it a couple of times, maybe even 3 times in 7th grade as well, or 8th grade. So I'm going to bring it back today, so it's going to go pretty fast because I want to make sure that we get the practice in. So once again, our main concept for today is quadratic equations. What are we looking at? Quadratic equations. What are we doing today? We're solving and graphing. Okay. So in your Freyer model, what goes in the center? Quadratic equations. Write that in there, please. Here it goes. Like I said, it's going a little bit faster, like this. Look up this fast. Watch. That fast. You didn't even see me move. Saw that, Carlos? Woo-wee. All right, quadratic equations. What are they, Mr. Q? Here it goes. They are 2 variable equations where the highest degree is 2. 2 variable equations where the highest degree is 2. Quadratic equations are 2 variable equations where the highest degree is 2. What are quadratic equations? 2 variable equations where the highest degree is 2. 2 variable equations where the highest degree is 2. What are quadratic equations? 2 variable equations where the highest degree is 2. Tell your neighbor the definition of quadratic equations. Yeah, you should know that by now. I repeated it 1,000 times. What do they look like? Copy this. Examples. X squared plus 3x plus 2 equals y. X squared minus 9 equals y. Y equals 3x squared minus 11x plus 6. Copy those. All right, here we go. Look up to the screen. According to the definition, we said that quadratic equations are what? 2 variable equations. Okay, that's pretty straightforward, Mr. Q. Yeah. But the highest degree is what? 2. So what does that mean by degree? So here it goes. Look up to the screen. I'm going to break it down just in case you forgot. Look up to the screen. Stop tapping on your... There it goes. Look at the first equation. Do you see 2 different types of variables? Yes, Mr. Q, X and Y. Is it an equation? Yes. Okay. What's the highest degree? Well, let's check. What is the degree of this one? 2. What is the degree of this one? 1. Because the exponent on the variable is a 1. What's the degree of this one? Well, it doesn't have a variable, so this one is 0. Look at this one. What's the degree of this one? What is the exponent on the variable? 1, so this is 1. So what is the highest degree? 2. That's why that's a quadratic equation. You're like, oh, snap. Look at the next one. What's the degree of that one? 2. Degree of that one? 0. Degree of that one? 1. What is the highest degree? Is it 2 different type of variables? Yes. Look at this one. Highest degree is 2. This is 1, 1, 0, so it's 2. All right. So now that we know what quadratic equations are, look at these. Before you copy them, look at this one. Look at that. And look at this. So start with this last one. Tell your neighbor why this one is not a quadratic equation. Why is this one not a quadratic equation? Why is that one not a quadratic equation? All right. Why is that one not? So let's see. Who haven't we called on in a while? Go with Yaretsi. Why is this one not a quadratic equation? The highest degree is 1. Ooh. So second degree is quadratic. First degree is known as linear equation. All right. How about these two? Why are these two not quadratic equations? Talk it out with your neighbor, and then Yaretsi is going to pass to someone. Why are those not quadratic equations? All right, good conversations. Yaretsi, pass someone. Sarah, why are these not quadratic equations? Look at these, and look at this, and look at the definition. All right, help her out. Jaime, why are these not quadratic equations? They don't have a y and they don't have a what, everyone? An equal sign. That is correct. These are not equations. So, write hashtag 2 variable equations, hashtag highest degree has to be 2. Is it coming back for some of you? Yes? All right, good. Like I said, I'm trying to clarify here before we get started and jump into the funner stuff. With that said, writing utensils down, look up to the screen, and just to keep you focused on this, can you close your Chromebooks? You'll open them up in a little bit. Here he goes. Don't copy this. I'm just going to do a quick review of something that you need for today's session and for something that we're going to need for the next concept that we're covering this week, which is systems. So here we go. In mathematics, we have 2 types of operations. We have 4 types, but we focus mainly on 2 types when we're talking about polynomials. Look up, please. We usually talk about multiplication. And the inverse of multiplication is what we call what, everyone? Division. But when you got to Algebra 1 or Algebra 2, you probably heard the word factoring. Factoring is division, in case they didn't explain it to you guys. What does that mean, Mr. Q? That means that when you divide, you end up with 2 numbers. Those 2 numbers is what we call factors. Are we there? For example, if I was to say, here's number 12, and I want to divide that by 4. So how many times does 4 fit into 12? 3 times. So 3 times 4 is 12. Subtract. That's 0. Well, guess what? This number and this number are known as factors. Why? Because if we multiply them, it gives us the original number we started with. Okay? So, really quick, I'm going to focus on factoring right now. All right? Let's see how well you remember. Y'all ready? Here it goes. X squared plus 5x plus 6. I need to factor that. That means I need to end up with two expressions multiplying each other to give me that first one. So here it goes. The way I instructed this, I said, all right, guys, we're going to start with something called the Power Rangers. Power Rangers? Yeah? There it is. All right, so I take this number, write it on top with a little multiplication sign. Don't copy this, I'm just reviewing. You should know this. Then I take this number and I write it down here with a plus. So my question is, what two numbers multiplied give me 6 that when you add them give us 5? Everyone? 3 and 2 or 2 and 3? I'm going to do 2 and 3 like Michael Jordan. So check this out. Hopefully your teachers explained to you that we got 2 and 3 from where? From there. Is that correct? So what's the only thing we didn't use? The x squared. Is that correct? So how can I factor x squared? X times x. Is that correct? And where did we get this from? From that. So this is plus 2 and plus 3. And these are my factors. You coming back? Yes? All right, here goes another one. X squared plus 3x plus 2. All right. My Power Rangers. One number goes on top, the 2 with a multiplication sign. What goes on the bottom? The 3 with an addition sign. So question, what two numbers multiply give me 2 that when you add them give us 3? 1 and 2. Okay, so we already used this. What have we used? The x squared. So how do we break up the x squared? X times x, and then we have plus 1 and plus 2. And these are called what? Factors. Why? Because they are multiplying and should give us the original number. Are we there so far? Okay. I mean, you can go. That's fine. But you're missing the main part. Here it goes. What if I gave you this? 3x squared plus 9x. And I need to factor that. You're like, wait a minute, Mr. Q. That doesn't have the third part. Yeah, so we can't use the Power Rangers. What can we use? Something that we call GCF, greatest common factor. So question, what number divides here that divides there? 3. What else do you see that they have in common? 1x. Each of them have at least 1x. Is that correct? So, if we took out the 3 and 1x, that leaves us with x plus, what is 9x divided by 3x? 3. And these are my factors. How are we doing? Good? All right. So, last but not least, here it goes. X squared plus 7x plus 3. All right, let's factor this. You're like, wait a minute, Mr. Q, this one has a number in the front. Well, let's see. This one didn't. That's why we were able to use that. This one didn't. Okay, so how do we factor these kinds? We can still use this. I'm going to show you a shortcut today. Here it goes. Look up. What number goes on top? I usually go with the last number. Is that correct? But since we have a number in the front, the coefficient, we're going to multiply that times that. That gives me 6. What's the middle number? The middle number is 7. Question, what two numbers multiplied give me 6 that when you add them give us 7? What two numbers multiplied give me 6 that when you add them give us 7? 1 and 6, is that correct? Okay, but watch. I can't use these like I did the other because now we have this that changes everything. So what do we do with that, Mr. Q? We do this. Look up. Where did I get that 2 from? From the number that goes in the front. And I asked the question, look up. Can I simplify this anymore? No. If I can't, guess what? This is one factor. You're like, what? Can I simplify this one anymore? Can I simplify this to lowest terms? Becomes what? 1 over thirds or x plus 3. These are my factors. This shortcut is called the Escalante method. Have you guys heard of that one before? No? What's that? No. An actual teacher from LA did it. And there's a movie out, if you guys want to watch, well, with your parents, watch that movie. It's called Stand and Deliver. Jaime Escalante. All right. Well, enough of that. We good? Good practice, yeah? Yeah, because I see someone you're like, oh, Mr. Q, I got this. All right. Then copy this. Example 1. X squared plus 14x plus 45 equals y. X squared plus 14x plus 45 equals y. It's going to go super fast, so stay with me. Here we go. We're going to solve and graph. All right, whenever you get an equation like this, first things first, it needs to be set equal to 0. So the first thing, we change the y to what? To 0. Bring everything else down. X squared plus 14x plus 45. Next, we need to factor whatever's left. So, what number goes on top? One number goes on top, 45, that is correct. One number goes underneath, 14. So, what two numbers multiplied give me 45 that when you add them give us 14? Tell your neighbor, what two numbers multiplied give me 45 when you add them give us 14? 9 and 5. Now, look at the x squared. Does this have a number in the front? No, so that means we can just break up the x squared as x times x, bring down the plus 9, and bring down the plus 5. And all that equal to 0. You guys remember this? Yes? Next. Here goes the next step. For those of you that didn't know why we did that, question. What is this times this? That times that is what? No. What is this whole thing times this whole thing? That is equal to what? To 0. Are we there so far? So let's think about this one. If I have a number times another number equal to 0, that means one of them has to be what? 0. A number times 0 is always 0. Is that correct? Do we know which one is 0? No, that's why we write x plus 9 could be 0 or x plus 5 could be 0. So, and from there we just solve. Here we go. What do we do to solve? Minus 9, x equals negative 9. Minus 5, x equals negative 5. Now, what are these called? These are called roots or x-intercepts. Hopefully that's sounding familiar. Yes? All right. Let's go to graph it. And you're like, what? Oh, yeah, we got this. All right. So what are my solutions? Negative 9 and what? Negative 5. So negative 9, let's say about right there. Negative 5 about right there. Now check this out. I need one more point on my graph. Look up. What is the constant here, or the number without a variable? The number is, which is way up here. I'm going to just label it 45. And now my graph should look like that. 2 x-intercepts and the y-intercept. From 1 to 5, how comfortable are you with that so far? Is it coming back? All right, we're going to do some more. But in the meantime, send me your notes, please. Oh, hold on. Never mind, let's go to the next problem. Copy this next one. Example 1Q. Now read, x squared minus 14x plus 48 equals y. X squared minus 14x plus 48 equals y. All right, here we go. What is our first step, everyone? Making y what? 0. So we got x squared minus 14x plus 48 equals 0. What do I do next? What number goes on top, everyone? 48. What number goes underneath? Negative 14. So question, what two numbers multiplied give me 48 when you add them give us negative 14? Think about it. I heard negative 6 and negative 8. Let's see, what is negative 6 times negative 8? Positive 48. What is negative 6 plus negative 8? Negative 14. Okay. So, does this x squared have a number in the front? No, so we can break it up into x times x. Is that correct? And what numbers did we come up with? Minus 6 and minus 8. What is our next step? Set each one equal to 0. X minus 6 equal to 0. X minus 8 equal to 0. Let's solve. Plus 6 plus 6. X equals 6. Plus 8 plus 8. X equals 8. All right, let's graph that. My x-intercepts are 6, 8. What is my y-intercept? 48, way up here, from left to right. From 1 to 5, how comfortable are you with that so far? Where are we at? 4, 4, 4, 5, okay. Send me your notes, please. I want to see what you did. Example 1, super duper Q. Negative 3x squared plus 18x minus 15 equals 0. All right, so look up, please. If you notice, this one has a number in the front. So before you go to the Power Rangers, I want you to see if there's a GCF that can divide all terms. What number can divide the first term, that can divide the second term, that can divide the third term? Very good, but if this one has a negative, then it's negative 3. So negative 3x squared divided by negative 3 is x squared. 18x divided by negative 3, that's negative 6x. And negative 15 divided by negative 3, that's positive 5. All right? Look at the inside of the parentheses. Tell your neighbor what to do for the inside of the parentheses. What do we do next? Does that look familiar? Yeah. What number goes on top? 5. What number goes underneath? Negative 6. So tell your neighbor two numbers that multiply to give us positive 5, and when you add them, give us negative 6. Two numbers. Negative 1, negative 5, or negative 5, negative 1. Either one, okay? So, bring down the negative 3. And then we're inside the parentheses, so we're going to break up the x squared into x times x. and then we bring down the negative 5, the negative 1, and all that equal to 0. Next. Now, some of you are getting really distracted, and you are very going to start like feeling it once we get into the next sessions. I'm just giving you this day of practice, this day only of practice. So please, pretty please, stay focused. What is the next step? Well, this equal to 0, this equal to 0, and that equal to 0. So negative 3 equal to 0, x minus 5 equal to 0, x minus 1 equal to 0. Question, is negative 3 equal to 0? No, so this cancels. Can I solve this one? Yes, plus 5 plus 5, x equals 5. How about this one? Plus 1, x equals 1. All right? Graph. What are my solutions? 5, 1. What is my y-intercept, people? Negative 15. So check this out. Since this has a negative in the front right here, that means that the curve is going to be upside down if we go from left to right. My first point is this one. Then it's going to come down like this. And is it upside down? Yes, Mr. Q. There you go. No, because it canceled out at the end. Because it's not equal to 0, so we just cancel it out. All right. Next, copy this one, example number 2. 2x squared plus 7x plus 3 equals y. 2x squared plus 7x plus 3 equals y. So, question, what is our first step, everyone? Change y to 0. So 2x squared plus 7x plus 3 equal to 0. Oh. Let it go. Let it go. Next. Is there a number that divides 2, that divides 7, that divides 3? No. So therefore, one number goes on top. The 3, but now it's times what? Times 2. So that is 6. Some of you are like, why did you do that, Mr. Q? Because now we have a number in the front. What goes on the bottom? The bottom is 7. So what two numbers multiplied gave me 6 that when you add them give us 7? 6 and 1, I'm going to do 1 and 6. Is that correct? 1 times 6 is 6. 1 plus 6 is 7. However, look up. What do we do with this? So, question. Can I simplify this anymore? No. So my first factor is 2x plus 1. Where'd you get that from, Mr. Q? From here. The top is the x. The bottom is a number. 2x plus 1. There it is. Question, can I simplify this anymore? Yes, this becomes 1 over 3. Therefore, the top is the x, the bottom is the number, so my factor is x plus 3. And all that equal to 0. What do we do next, everyone? 2x plus 1 equal to 0. X plus 3 equal to 0. Solve. Minus 1, 2x equals negative 1. In our last step, divide by 2, so x equals negative 1/2. The other one, minus 3, x equals negative 3. Our quick graph, let's see. Negative 3, negative 1/2. What is my y-intercept? My y-intercept is positive 3. So, my graph. From 1 to 5, I've come to where are you with this so far? Where are we at? 4, 5. It's coming back, right? All right. Well, enough of those easy ones. How about them apples? Let's move on to this one. Copy this one, please. Example number 3. X squared minus 5x equals y. X squared minus 5x equals y. X squared minus 5x equals y. Step 1, everyone. Set it equal to 0. So we got x squared minus 5x equals to 0. You're like, wait a minute, Mr. Q, it's no longer a trinomial. We can't use the power ratio. No. But is there a GCF? Do those two terms have something in common? An x, is that correct? So, if we take out an x from here, we're left with x. If we take out an x from here, what do we have left? Negative 5, and all that equal to 0. What is our next step? Set each of these equal to 0. X equal to 0. X minus 5 equal to 0. And let's solve. You're like, oh, this one's already solved. Yep, there it is. What is the other one? Plus 5 plus 5, x equals 5. And what does that look like in a graph? Let's see. X is 0. X is 5. Now, question, look up. Does this have a number at the end by itself? That means it's going to cross at what? At 0. Let's go. All right. And the last one. I know some of you are starting to pack up. Look at this one. Example number 4. Again, set it equal to 0. X squared minus 16 equal to 0. Now check this out. This looks weird because it's called a difference of squares. How do you know, Mr. Q? Well, let's see. Can we take the square root of that? Yes. Can we take the square root of this? Yes. So therefore, my factors are x plus 4, x minus 4, all that equal to 0, and then you know what to do from there. All right, guys, have a good one. Enjoy your home play. See you guys tomorrow. Bye.